Hi everyone, my name is Mr. MVJ Kuma, an engineering lecturer from Nkangala TVET College in the Mpumalanga province. Today I'm going to facilitate a lesson from the program Engineering and Related Design. The subject is Engineering Systems Level 2, and then the topic that I'm going to do is topic 2. Before I start with the subject outcomes and the learning outcome, I just want us to check the marks allocation for this subject. Engineering Systems Level 2, it is having 3 topics. Topic 1, which is having 50%, and then topic 2, that we are going to do right now, which is having 25%, and lastly, topic 3, that is also having 25%. So it is very important when you are preparing to know the mark allocations, because previously in term 1 from January up to 15 March, we managed to cover topic 1, that is having a half of the whole syllabus. Now we are going to deal with topic 2, that is having 25%. And now if you do your mathematics correctly, you'll see that now we are entering into a 75% of the work of the whole system. Now, the subject outcome that is given to us, it says we should identify equipment with simple control systems. And now, one will ask the question, what is these control systems? If I go to the basics where everybody understands or would know better, I'll take a traffic light, for instance. A traffic light is a simple control system. I remember in the old days when we are still at preschool, we used to call this a robot. The color of the robot is red, amber, and green. And we know that green says go, and red says stop, and then amber says be caution. Now, a traffic light, it is able to control thousands and thousands of vehicles without anybody using it. Now I want us to go to the learning outcomes. The learning outcome number 1, it says we should identify equipment with simple control systems. Now this equipment with simple control systems, they are categorized in different sectors. We have engineering, we have mining, we have textiles, we have food industry, and other domestic sector. In engineering, we have equipment such as the press, we have the lathe. Oh, my space is so small, but I'll try to put at least 2 or more. We also have the woodworking machine. And lastly, we have surface grinder. Oh, my space is so small. Let me try to create the space so that it will be nice and neat. Now, in the mining industry, we can have conveyor, we can have refrigeration unit, we have also compressors and turbines. Now, before I continue, let me try to explain a little bit about what is written here. From engineering, a woodworking machine is the one that can be used for carpentry, manufacturing of carpets, and so on. A lathe machine, it can be used in a fitting and turning workshop to cut different designs. A surface grinder is the one that can be used for cutting different metals. Well, in engineering, in mining, we have conveyors. The conveyors, they are usually used to carry loads. For instance, in the area around the Malahleni, we have coal mining. How they load the trucks, they use the conveyor belt that will move coals from one point to another. Maybe one will ask themselves the question to say, what is this conveyor? If I can make an example, when you are in a supermarket and doing some groceries, you find that there is a belt that is next to the teller. You put your groceries, and then for the teller to bring them closer, he or she will just press a button, and the groceries will move closer to the teller. So that is a basic example of a conveyor belt. Now, we have refrigeration unit. Example of a refrigeration unit, it will be an aircon system. In the mining industry underground, they need fresh air. And then so a refrigeration unit, it is really in need. We also have compressors. The compressors are used for different operations. For instance, we can operate tools by means of compressors. And we also have a turbine that can be used for power generation. Right. The next example of these equipments, we have the textile. So in the textile industries, usually these are the industries that are doing spinning. They use with the spinning machine, weaving machine, and knitting. If I could give an example, there are people who are in a recycle business. They need these bags that they are going to put bottles. So these bags are being knitted or they use weaving machines. Textile, they use spinning, and knitting machines. Then we have also bottling, that this falls under food industry. Food industry, they use bottling and also packaging machines. If I may give one example there, and I want to create a structure that is having 4 bottles that are going to be poured with maybe a beverage drink. Now, a nozzle will be focused in the first 1, 2, 3, 4 bottles. So there will be a code that is going to be registered on a machine such as CNC machine. I'll discuss that machine later. It will be recorded to say now, it will be programmed actually to say that it should pour the drink into the bottle, the first bottle, the second bottle, the third bottle, and the fourth bottle, and then from there it will move to the other place where maybe the bottles will be put with their caps, and then the same sequence can be used. And also with packaging of food parcels, there are machines that are used, and then also CNC machines can also be used there. We also have a domestic and domestic equipment such as the traffic lights that I talked about earlier on. Maybe if you can even look not very far from our household, we have a simple washing machine. A simple washing machine is having a simple control system where, for instance, you can take your washing and put it in the machine, and then you set to say how long you are going to wash the machine. For instance, for 50, how long are you going to wash your clothes? for 15 minutes, and then you can select to say you're going to use hot or cold water. And the machine must do the rinsing, and after that it will just do the tumble dry. That's basically, that will be a simple control system that we have from our household. Then I want us to talk about the functions of these simple control systems. These control systems, they can change the speed of motion. They can change the direction of motion. If I'm talking about these control systems, I'll make an example with a electric gate. An electric gate is able to go to the clockwise direction, which is going to close the gate, and on the other side, anti-clockwise direction, which is going to open the gate. And this function of, they can also change the direction of rotation. I don't want to spend more time with these examples. I think the book that I'm using is this of engineering system with the publishers from Heinemann. The students can look into those examples in that book. Right. Let's carry on now. I just want us to discuss different abbreviations that are also used in this control. I think most of us, we know these abbreviations: CNC, PLC, CPU, and maybe if I can also put the IC. Now, what does this abbreviation mean, CNC? It is a computer numerical control. Actually, what is this computer numerical control? This is a computer that is used in the industry for mass production. It is a computer used in the industry for mass production. And now we have the other abbreviation, PLC. Programmable logic control. Then exactly what are these programmable logic control? This is the computer that is used in the automation industry. Maybe some of our learners, they are asking themselves, what is this automation industry? Automation machines are the machines that are used instead of people being employed in the industry. If I may say it, I just want to check it exactly from the book. Say automation are systems that are used, systems that uses machine to do work instead of people. Automation systems in the machine that are used instead of people. So which means if the industry is using automation, there are very less people that are used. Then we have the CPU. the central processing unit. I think people who are doing computer studies, they know better about this one. This CPU, central processing unit, it is the one that holds the memory of any PLC system. And lastly, we have the IC. The IC, it is actually the integrated circuit. The IC, some they call it a microprocessor, or a small computer. If you may allow me, maybe I'll just try to draw a simple sketch or a representation of how a small computer can be like. I'm not a good artist, but I'll try for the information to reach our candidates. Right. That will be an example of an IC or integrated circuit. Or let me write the IC, that is abbreviation for integrated circuit, of which the integrated circuit, it is also referred as the microprocessor or a small computer. But some people, they refer to it as a chip. Now, with this microprocessor or a chip, you can store lots of information. I'll make an example in electronics. This microchip, it can be used as an amplifier. For example, your television is able to broadcast something that is being recorded somewhere in Johannesburg while you are in Mpumalanga. How is your television achieving that? There is an amplifier in a chip or in a microprocessor that will amplify a frequency, and then you are able to see a clear picture of exactly what is happening at the very same time. Also, it can also amplify the sound. You can able to increase the volume or decrease the volume. This is by means of this microprocessor. You can even store important information. I think with the abbreviations, that's where I'll stop, and I'll move to check different types of these control systems. Let's look into examples of the control systems. We have the Electron Control. When we talk about electron control, basically we are talking about sensors. And nowadays, we have, for example, vehicles that are having rain sensors. You don't need to switch on your wiper motors. Immediately when there are droplets of water on your windscreen, then a rain sensor will just wipe to show that there was water on it. But let's quickly check the examples of these sensors. We have the temperature, temperature gauge, we have the pressure gauge, we have switches like thermal switch, and we have a thermostat. And lastly, proximity switch. If I may make an example with the temperature gauge. A motor vehicle operates at a certain temperature, right? For instance, if the temperature is exceeded, a temperature gauge which is linked to a sensor will switch on a cooling fan so that the temperature will go back to its normal or constant temperature. Let's look into another example of this control system. We have the electrical control. Now, one example of the electrical control that I like is the micro switch. Now, the micro switch, it is having two good examples, if I may state them. It is only need a small force to operate. And the force should only act over a small distance. For example, a handbrake of an automobile that is using a micro switch, you can operate it with just a finger, pulling it to be on. And it moves only for a small distance. Now, a mechanical handbrake of an automobile, you pull it, and as you pull it, you use more energy. The one that is using a micro switch, even a child, he can use just a tip of a finger to switch it on or off. That is an example of a micro switch from the electrical control. The other example, it is the semi-auto control. I think this one, most of us, we are familiar with. The semi-control basically is that one, a remote control of an electric gate or a remote control of a motorized garage door. As you select or switching on the motor by means of a remote control, what will happen? The energy will be supplied to the motor and the gate will start to move until there is a switch, a limit switch. As the gate ends, it will stop the motor operating. Right, I think these two examples is enough. Let's look into another two examples. The two examples of these control systems that are utilized in the industry. We have a mechanical control. Now, there are two examples of this mechanical control. We have the brakes and the clutch. Now, the brake systems, they usually use the two things. It's either you reduce the speed, or stop any motion. Hence the clutch, it is used to mesh or to couple a driving shaft from the driven shaft. Hence, in a simple form, we say to engage the gear in an automobile. Don't be surprised, you see most of the example that I'm offering here is from automotive repair and maintenance. That is my field of specialization. And the last example, it will be the one for hydraulics control. Hydraulic control. How do we achieve control by means of this device? We make use of the stop valves. Relief valves, and lastly, reverse valve. Like the name implies, the stop would be able to stop any motions. The hydraulic system and pneumatic systems, they use the same components: the stop valve, the relief valve, and the reverse valve. As the name says, reverse, which means it can change the direction from forward to reverse. And the relief, if the system is overwhelmed, it will bring the pressure into a uniform standard. I think you've enjoyed the lesson, and then all the best with your studies.